Hello and welcome. In this section, we're going to do question 8 from the 6th of January 2020 Csec Mathematics Past Paper 2. So let's go to question 8. So here you have a pair of simultaneous equations and you're required to solve them. And this is section 2 and you're required to answer all questions in this section. So 8a, you're required to solve the equations. Now, it's really important for you to know that equation 1 is equal to x, but also equation 2 is equal to x. So let's label this as equation 1 and this one as equation 2. Both equations are equal to x, so it means that we can have y squared plus 2y plus 11. Since they both equal to x, it means that we can have both of them equal. So that would equal to 5 minus 3y. And we can solve for y first. So by taking, we want the right hand side to be 0. So by taking 5 both sides, we would have positive 6. And by adding 3y both sides, we would have 5y. So the right hand side is equal to 0, and then we had plus y squared. So now we can factorize the equation and solve for y. So we want two factors of positive 6, and when we add them, we get positive 5. And straight away here, I can see that it's 2 and 3. So y plus 2 and y plus 3. So we have two things multiplying to give us 0, which means that either of them could be 0. Hence, y plus 2 equals 0, or y plus 3 equals 0. So we can solve for y. So y equals to minus 2 or y equals to minus 3. Okay, so now we can solve for x from equation 2. So from equation 2, we can solve for x. So when y equals minus 2, from equation 2 we would have x is equal to 5 minus 3 times minus 2, and that gives us 11. So we can write this as an ordered pair, so it means that we can have 11 and minus 2. Okay, so that's one solution there. Okay, when from equation 2, when y is minus 3, we can have x equals to 5 minus 3 times minus 3, and that's 14. Again, we can write this as an ordered pair, so we have 14 and then minus 3. So the solution of the equation there is given as that one, as that, and that. Okay. So let's move on to the next part of the question. So part B of the question, it says the function is defined as f of x equals to 4x squared minus 8x minus 2, and you're required to express it in the form a into x plus h all squared plus k, where a, h, and k are constants. So we need to make these two functions here equal. So we have 4x squared minus 8x minus 2. We want to express it into the form that is identical to a into x plus h all squared plus k. Okay, so you can either work on the left hand side and make it equal to this side, or you can work on the right hand side and make it equal to the left hand side. So what I'm going to do, I'm going to work on the right hand side and equate it to the left hand side. So if you haven't done that before, I'll show you how to do it. So you expand x plus h all squared. So x plus h all squared means that you times it by itself. And upon expanding this, what you get there is x squared plus 2hx plus h squared. So you're going to multiply this bit by a. So we're going to have a times x squared, there's ax squared, plus, let's just put the bracket there, times that by a. So a into that is ax squared, and a into that is 2ahx. Okay, so it's 2ahx plus a times h squared is a h squared plus k. Right. We can equate the coefficients now, and we can solve for the values of a, h, and k. So that equals to 4x squared minus 8x minus 2. So let's just identify the coefficients here. This bit here and that bit are equal, so we're going to have we're going to have ax squared equals to 4x squared. That's one of them. It's one of the coefficients that we equal. That means a equals to 4. This coefficient now, that bit, okay. So this middle bit here must equal to minus 8x. So we have 2ahx must equal to minus 8x. We know the value of a as 4, so it means that we can have 2 times 4 hx equals to minus 8x. So from this we get h equals minus 1. So we have found that. And then the last bit, ah plus k must equal to minus 2. So we have ah squared plus k, must equal to minus 2. We know the values of a and h. A is 4, h is minus 1 squared plus k equals minus 2. So what we get there is 4 plus k equals minus 2. So it means that k equals to minus 6. So now we have found the values of a, h, and k, so we can write the equivalent expression, that equivalent. So we can write it as left hand side is equal to the right hand side. We're going to have 4x squared minus 8x minus 2. That must equal to the right hand side. We know a as 4, so we're going to have 4 into x minus h as minus 1 all squared, and k is minus 6. So that's equivalent. Okay, now let's move to the next part of the question. They want the minimum value. Now if you should make a sketch of the graph, so the graph, let's make a sketch here just to show you what we have there. Alright, let's just get this properly done. Okay, so we have a sketch of our graph there, right? That's our y-axis, and that would be our x-axis. Now we know that the graph cuts the y-axis at minus 2, So minus 2 would be somewhere here. Okay, minus 2 would be somewhere there. X minus 1 here is the equation of the line of symmetry. So that bit there, x minus 1 must equal to 0. So we know the equation of the axis of symmetry as positive 1. So positive 1 would be somewhere there on our x-axis. The graph is cutting it here, and the minimum value is minus 6. So the minimum value is going to be the lowest point on the curve there, like that. Okay. Alright, this is not so glorious with this pen. Okay, so that's the sketch of our graph there. So the minimum value is this value here, and the axis of symmetry is x equals positive 1. Alright, so minimum is minus 6. So min equals minus 6. And the next part there, axis of symmetry there would be x equals 1. So all you need to do is to equate this little bit here, x minus 1 equals 0, and find x, so x equals 1. X equals 1. Okay, so let's move on to the next part of the question. Okay, so here we have a speed time graph. It's not drawn to scale, and there are 3 stages of a journey: stage 1, 2, and 3. And the period of time there, maximum is 40 seconds, and the velocity there is 12 meters per second. Okay, so determine the acceleration of each stage of the journey. So stage 2, the velocity there is constant, therefore acceleration equals to 0. So the acceleration there is 0 meters per second square. So acceleration there would be 0 meters per second square. That's stage 2. Because the velocity is not changing, it's just constant. Let's look at the next part of the question. Stage 3. Okay, so when we look at stage 3 there, we can see that the velocity is 12 meters per second. That's 12. And the time between here and here is just 8 seconds, yeah? And we know that acceleration is velocity over time. But with this here, the graph is sloping downwards, it's decelerating or slowing down, so it's going to be a minus velocity. So acceleration, so that's going to be minus 12. So acceleration is the velocity over time, so it's 12 minus 12 over the time as 8 seconds. So what we get there is 1.5 meter per second, minus 1.5 meter per second square. So stage 3, the acceleration there is going to be minus 12 over the time, which is 8. So that's minus 1.5 meter per second square. Okay? So here ends question 8 of the question.